Hello everyone and welcome in VHDL Learn by Example series. This is the episode 2 of this series, and in this episode we are going to create LED blink program. It may sound a very simple task. That's because we choose this example for the second episode of this series, but it is not very simple as it may sound. If you had created the timers in any previous embedded system development, the traditional embedded system development like in C or assembly language programming, you may know that how to use the peripheral of timers to create the precise delays. As we do not have any timer peripheral in VHDL or any other FPGA, so we have to create our own peripheral because we are going to create our own circuits in the VHDL. So this is the similar task. We are not going to use any for loop or nested for loop. All we have to do is to create the sequential program to create this task. So what you will be learning in this tutorial is that you will be aware how to create a process in a VHDL, how to create the sequential logic, how to implement the sequential logic in VHDL, and how to create a blinky program in the VHDL and the FPGA. We are using the board of Nexys 3. You will also learn how to use the clock of the FPGA and how to create the timers and how to create a precise delay, how to create a clock divider. That's all gonna come ahead, so stay tuned with us. Let's start by creating a new project. You can name this project anything you like, but I am going to name it a Blinky EX01. So after you name your project, click on the next, and here you need to select your configuration of your board, and in my case it is Spartan 6 XC6SLX16, and all this configuration I choose preferred language of VHDL and click on next and finish. You had also seen this process, a very similar process in our first episode where we created a LED on off logic where we connected directly the LED to the switch. So now you are here in the hierarchy of your project. Here you need to create a new source file. To create a new source file, you need to choose the VHDL module. You can name it anything you like, and I'm going to name it same as my project, Blinky EX01. So this is my LED blinking package where I need to create the behavior, and I need to input a clock which is an input direction, and I need to create an LED which is going to direct it output. So LED is an output and clock is an input signal. These are the two ports that we are going to use in our today's episode project and in today's example. So here you may notice that we had a statement of use IEEE.stdlogic_1164.all. If you had previous experience in any other previous programming language like C or C++, so this is similar like in sharp including header file. So these are the use keyword is going to refer if you are going to use something from the default packages. So it is the default packages, and here we have our entity which have two ports, a clock and LED. Clock is input and LED is output, and here we are. So in the beginning, what we need to do is we need to create a sequential thing. So anything you write here is concurrent. It means that it will be process parallel. So we do not want to implement the logic parallel. Like what we need to do is we need to first of all we need to create our LED is equal to 0, and we need to take some delay, and this delay could be, we are going to use 500 millisecond delay, and after that we are going to make the LED is equal to 1, and after that we need to take again a delay of the 500 millisecond. So this is our overall code that we need to implement. You may say that this code cannot be implemented. You may notice that this code cannot be implemented concurrently. So we need to do this sequentially. We need to take a first step, and after the first step is completed, we need to do the second step, and after the second step is completed, which is the delay is passed, 500 millisecond has been passed. After that we need to make the LED 1, and after that we need to create another delay. Although we can short out this code by simply doing like something similar like toggling the LED, which is to not LED like this. So we can toggle the LED and then take the delay, and over this still it is a sequential process. We need to do this in a two step. Well, you need to notice that LED is an output, and here we are reading the LED, and we cannot do this. So we cannot read the output pin. We can only read the input pin, which is the clock pin. So if we want to read and write as well, we need to change the in out to the LED. We are not going to do that. So what we are going to do is we are introducing a new term, which is a signal. So we are creating a wire, you can say, which could be read and write as well. So we are creating a signal to replace this, and after that we are concurrently attaching that signal to the LED. So our sequential task will be simplified, and our sequential task will only be dealing with the clock signal. So that's our program that we are going to implement. So how to do this in a VHDL? You may aware that if you are going to do this in a C++, you can simply create a for loop like something I is equal to 0, and you may say that I is less than 500 and I plus plus, and you can take the delay of 1 millisecond, and you can toggle the LED with any function of the helper function. But we cannot do this in the VHDL. In VHDL, to implement the sequential logic, we need to add a process. So anything that goes into the process is going to simply implemented in a sequential manner. So if we are going to if we want some piece of code to be executed sequentially like we are used to implementing in the C++ or any other embedded system programming, which is a sequential programming, so we need to create a process. We are not going to in a deeper detail of the processes. We will be seeing how to use this process. So we are passing this process as some argument of the clock. So now what we need to do is that we need to use this process to divide the clock. In case of our FPGA of Nexus 3, we have 100 megahertz clock. So in 100 megahertz clock, what we need to do, we need to create a 500 millisecond delay. So 100 megahertz means that 100 million clocks are passing in 1 second. So if we need to implement a 1 hertz cycle, what we need to do is create a 500 millisecond count. So to count the 500 millisecond, we need to count up to the half of the 100 megahertz. So what is the half of the 100 is the 50 million. So we need to count till the 50 million. So as it sound that we need a register to count up to the 50 million. So what we are going to use for the counting process, we are going to create a vector signal. It means that we are creating a array of the bits, which is called the vector in VHDL. You may argue that we should use the signal of the clock counter with natural range from 0 to 50 million and initialize this with the 0. You need to put a semicolon at end of the statement. Well, we stick with that for the sake of the moment, and here in the process what we need to do is to begin our process so that we could use the process. The benefit of creating a signal is that we can use, this is a global kind of variable which could be used in any process, so we can use it in the clock process. Here we need to wait for a positive edge, which is the rising edge of the clock. Rising edge of the the rising edge of the clock signal. So if it is a rising edge, we need to increment the clock counter. So we need to create a if statement here which is going to take care of the positive edge of the clock. So if here we need if we have a positive edge or a rising edge of the clock, what we are going to do, we are going to increment our clock counter. To increment a signal variable, we need to use the angle bracket or less than equal to sign. This is an assignment operator for the signal kind of variables. So the clock counter will be incremented. Clock counter +1, right? After that, we need to check if the clock counter is greater than equal to the 50 million then what we need to do, here we need an other signal. I name it a blinker, and this will be kind of STD logic, and initial value is set to the 0. After that, here all we have to do is to toggle the blinker and reset the clock counter. Once we are done with this, let's try to synthesize and see if everything is okay. So this synthesis process is running, and it will be. So the synthesize process is completed with the green tick. It means everything seems so fine so far. Finally, what we are going to do is we are going to attach the LED with the blinker, and we are good to go so far. So let's synthesize again and implement the design so that we can add the constraint file. For the constraint file, we need to know the respective pin numbers that we are going to attach with the LED and the clock. For that, we need to refer with the reference manual of our respective board, which in our case is Nexus 3 reference manual. And here we need to find out the LED. We are going to use the first LED, and we need to come down and see the pin of the LED and the pin number of the clock. So the LEDs are attached with the pin of U16. So we are going to use the U16, and for the clock what we are going to do is we are coming down and seeing the clock section, and we need to find out where the clock is mentioned in this reference manual. Here we have the oscillators and clocks. So here it is saying, wait a second, lost track of this again. Let's get back to, yeah, now we have this. It says that the Nexus 3 board includes a single 100 MHz CMOS oscillator connected to the pin V10. So we are going to use the V10 pin for the clock signal. So here we find out that our oscillator is 100 MHz and the pin is V10. So these are the two information that we are going to use for our clock signal, V10 and 100 MHz. And the second thing of the LED we are going to use is the pin number of U16. Coming back to our project navigator, here we need to create a new constraint file. We need to add a constraint file. We can also do this from the user constraints and IO planning pre-synthesis, and it will ask for you to yes, and over a file of Blinky UCF is added, and we are opening it into the text editor, and all we are going to do is to add over constraint file information here. So what we are going to do is net in the course LED, and we need to lock it with equal to U16, and we also need to lock down the clock. Lock is equal to V10. So that's all for our UCF file or the constraint file. Coming back to our make sure that you had selected the over top behavior and implement the design again. Once implementation is done, you are ready to build your programming file. Click on the generate programming file. Once the programming file is generated, you may test this code by running on the target FPGA. Open the adapt, connect your target FPGA board with the USB port of the computer, and it will select the Nexus 3 board by default, and browse to the respective coding file, of which is in our case is Blinky EX01, and navigate to the .bit file and program to the microcontroller, the FPGA board. And once the programming is successful, you are ready to see your LED blinking at 1 Hz rate.